afternoon, everyone, or morning, depending on where you're joining us from today. My name's Ashley, and I'm a structural engineer in our Saskatoon office. I want to welcome you to session 3.3, focusing on mass timber and prefabrication of buildings. We're going to have two presentations in this session, with time for questions following each presentation. I'll remind you to submit any questions in the questions tab on the panel on the right-hand side of your screen, and at the end of each presentation, I will go through those with our presenters. We'll get started with our first presentation by Jermyn Wong out of our Vancouver office. Jermyn's experienced in the design of all materials. He combines different materials in a sensible manner, putting each material to its best use. He's completed numerous timber and timber hybrid projects, including several award-winning ones. He's a mass timber course instructor with the Structural Engineers Association of BC. Today he'll be presenting on the use of mass timber in diverse applications. Since mass timber structures can be rapidly constructed and more readily disassembled than other materials, they can contribute to community resilience. Their properties are also instrumental to climate change mitigation. Mass timber such as CLT is a very versatile, and besides mainstream commercial and industrial applications, we've successfully used it in industrial, recreational, research, and wastewater facilities. This presentation will walk you through some of the innovative structural solutions that were used in our projects. So welcome, Jermyn, and we'll get started.
Thanks, Ashley. So good morning, everyone. Welcome to my presentation, Embracing Mass Timber in Diverse Applications. I was secretly hoping that the turnout at this presentation wouldn't be that great and it would be canceled, but it looks like my wish didn't come true. So I gotta move on and embrace the challenge, like the title of the presentation. So I'm just trying to click onto there's something, okay, now it's working now. So first of all, a bit of an outline. I'm first of all going to touch on mass timber and how it contributes to resilience. And then we're going to look at associated engineering's journey through mass timber projects. And then we're going to look at some projects more closely, specifically. First of all, mass timber typically consists of prefabricated components such as roof panels, floor panels, and wall panels, etc. And these panels typically allow for fairly rapid construction on site, and the components are fairly lightweight, which makes them easier to disassemble, perhaps, compared to more conventional materials. And also, timber is carbon sequestering. If we look more closely at what I call the micro properties, mass timber can be designed as seismic resisting systems, for example, cross-laminated timber or CLT shear walls. And they can be designed with ductile detailing to perform satisfactorily in earthquakes. And this leads to seismic resilience. And mass timber can be designed with proper fire protection, either by encapsulating them in assemblies or by accounting for charring effects. And this leads to fire resilience. And mass timber wall systems and roof systems typically or may have less thermal bridging and more uniform thermal performance than, say, conventional stud or joist systems. This leads to better energy efficiency, and that which can handle maybe more extreme climate or extreme temperature events more readily. But it also leads to climate change mitigation, which goes hand in hand with resilience. And if we look at some of the more global or what I call macro properties, the ability to rapidly construct mass timber structures may potentially allow for quicker erection of temporary shelters in times of disaster. And this can lead to community resilience. And rapid construction can also help mitigate potential weather impact due to a shorter or condensed construction schedule, leading to construction resilience in a temporary sense. And like I said before, mass timber can be more readily disassembled, can be reused, salvaged, recycled, and has less wastage. This can enhance the life cycle performance of this material compared to some other more conventional materials, potentially. And lastly, mass timber is carbon sequestering. This means there's less impact to the environment, and this leads to climate change mitigation, which once again goes hand in hand with resilience. So moving on, here's a bit of a timeline of Associated Engineering's mass timber journey. So you can see a windy road here, but I'm not trying to say that it's been a difficult or challenging road. Rather, I'm trying to portray the fact that at every turn or at every corner of the journey, we made new discoveries and we found new innovations as we tackled each project. So moving on, let's look at some of the innovative solutions we employed on some of these projects. First one, Wood Innovation Design Center. So this building is a 6-story mass timber building in Prince George, and it is the campus for UNBC. We were the owner's engineer for this project, and we were responsible for developing a site-specific regulation because at the time the code didn't allow for such tall timber buildings. And we were also responsible for developing an indicative design for this project. Because we weren't the primary designer, I'm not going to steal the glory, but I still want to show a couple of photos. So this is the atrium space showing some cross-laminated timber or CLT panels supported on glulam post and beams and the mass timber stair. And here's another picture of the atrium space. And we won an ACECBC Owner's Engineer Award for this project. So let's move on to some projects that we actually did the primary design for. The next one is Kam Freightway Terminals. This one, we designed 2 freightway terminals, one in Kelowna and one in Prince George. And the interesting thing about this one is that it's a bit of an unusual application in some ways. So on the left-hand side, you can see a warehouse with truck bays that's built in pre-ench steel. And then on the right-hand side, there's this mass timber 2-story office structure that's attached to the warehouse. And the mass timber structure is primarily CLT or cross-laminated timber floor panels supported on CLT walls, glulam posted beams, and stud walls. So here's the inside of the building during construction. You can see some wood structural insulated panels for the roof and the exterior walls, and glulam posted beams on the inside. Here's another photo showing CLT floor panels cantilevering past the edge to form an overhang. More exterior photos showing glulam posted beams both inside and outside. And this is a photo showing the combined warehouse on the left and in the office 2-story structure to the right. This is another overview. And this is the office side. And then moving to the inside of the office, this is the finished space with some of the glulam beams still exposed for visual effect. And this is the control room. You can see through the windows that you can see the warehouse built in pre-ench steel. So a pretty unusual application, a combination of a more industrial structure with a mass timber office space. And this is the stair shaft in the office space made in CLT. Moving on, the next project is Kinsmen Park Train Station. So the Kinsmen Park train station is a miniature train station in an amusement park in Saskatoon. And this is a plan showing the roof. So the roof measures about 5,000 square feet, and it was built in CLT, supported on a combination of precast concrete columns along the planned north edge, and a series of wood stud walls cladded in metal along the south edge, the planned south edge. And one of the main challenges was laying out the panels. So CLT panels are typically prefabricated in up to widths of 8 feet to 10 feet or so, and they can, in the length direction, they can be prefabricated in lengths of up to 40 feet or longer. And so we elected to arrange the panels in this way, as shown in yellow, spanning from north to south. But you can see that each panel is only supported at 3 points, and that doesn't allow for a very good support condition. So what we ended up doing is we introduced a concealed steel member in red along the north edge, as shown by the red line there. And it's basically acting as a stiffening transfer beam that picks up the north edge of the CLT panel and then redirects or transfers loads to the stiffer points of the CLT that are cantilevering past the precast concrete columns. And we're essentially creating a hybrid structure that has timber and steel in it. So here's a section through the train station showing these elements. At the far right, at the top edge of the roof, you can see that steel trimmer member that's acting as a concealed stiffening transfer beam. At the lower edge, you can see a steel rain gutter that's doing double duty as a stiffening member as well. A pretty innovative way to combine steel and timber to enhance the structural performance. Here's a screenshot of the analysis model for the roof panels. And these are some construction photos showing the stud walls before they were cladded in metal. The precast concrete columns supporting the CLT roof. This is the completed structure showing all the metal cladded stud walls. This is the train in operation. You can also see clear story glazing in the station. This is another completed photo and yet another view here. So we won a landscape architecture award actually for this building. Moving on, the next project is the Tsawwassen First Nations sewage treatment plant in Tsawwassen, BC. The most unusual aspect about this project is that it is a wastewater treatment plant and a post-disaster facility. So I consider this to be a fairly unprecedented use of mass timber at the time for this particular application. So this is the process building, and it's a two-story structure, and this is a section view. So because of the more aggressive processes and potentially more traffic and impact for the lower story, we adopted a more masonry walls and its concrete suspended slab for more robustness and durability. But for the upper part of the structure or the upper story, because the processes are less aggressive, we elected to go with wood I-joist roof framing supported on CLT walls. And this also helped lower the seismic mass significantly for this post-disaster structure, and not to mention the quicker installation schedule. So here's the other section view showing the other direction. And then the other building at this facility is the operations building. There's an upper roof and a lower roof and a clear story. And here's a section through this building showing, again, wood I-joist roof framing supported on CLT walls. Another unusual aspect is that this upper structure, the operations building, is actually perched on top of the concrete equalization tank. Here's the other section view showing the upper and the lower roofs and the clear story, all sitting on a concrete tank. And we designed CLT shear walls for these two buildings at the treatment plant. And the main principles of CLT shear walls are that you have to design for a base for the base shear, sliding shear connection along the bottom of the walls, and you have to design for hold downs to take the overturning forces. But you also have to design interpanel connections between adjacent wall panels. And this interpanel connection is also an energy dissipating connection, and it's very important. And what's often done is that the interpanel connection is either done as a half-lap connection, as shown in case A in plan view, or what's called a spline connection, as shown in case B on plan view. And we went with the spline connection for this project. So just want to show some pictures. These are the roof I-joists supported off of an LSL ledger that's screwed to the face of the CLT wall in the process building. This is the outside of the process building during construction. This is another photo taken from the outside of the process building showing the spline connections between the vertical seams of adjacent wall panels. You can also see a PSL beam that's acting as a drag strut that's taking drag forces into the rest of the shear wall via metal straps. This is the inside of the process building. This is the outside with all the finished cladding and stuff like that. And then going back inside the process building again, in order to protect the wall panels from vapors and splashes of the processes, we not only had to apply a marine type of varnish or sealer on the CLT panels, but to provide additional impact and abrasion resistance, we also had to apply a fiber reinforced type of liner product near the bottom 3 or 4 feet or so, as shown in white there on that wall panel. And then this is the operations building during construction, showing the clear story windows. Those little wall piers between the windows had to be detailed with metal straps to take overturning forces into the lower part of the shear walls. And then more construction photos for the operations building, showing temporary strut bracing for the walls, as well as in the middle photo on the far right, you can see hold down, tension hold downs, taking overturning forces into the concrete structure below. A couple more photos, and on the left you see another spline connection between adjacent shear wall panels. And right-hand side, you can see a progress photo of the operations building on the concrete tank below. And here's another progress photo showing further progress. On the left here is the main hallway of the operations building, all done in CLT, as you can see. And on the right, you can see some exposed roof framing supported off of a gable-end CLT wall. And this is the completed building with all the cladding and the finishes. Moving on, the next project is Whistler Bus Shelter. So this project is a large roof area made of CLT supported on intersecting double glulam beams, a grid work of glulam beams basically that are intersecting each other at nodes. And the nodes are made of steel and steel columns. And our role was not the primary designer. Rather, we were retained by the contractor to design some of the connections for the CLT and the glulams. So I'm not going to steal the glory for this project because we didn't come up with the concept originally, but we did put in a lot of work to help make the construction viable and the installation process smoother. So a couple of pictures here on the right-hand side is the intersecting gridwork of glulams with all the shoring and stuff like that still in place. And then on the left is a screenshot of the shop model showing how the glulam pieces fit together. And here's the completed structure showing those steel nodes or columns supporting the intersecting glulam beams, which in turn support the CLT roof. The next project is the Anandia Cannabis Innovation Center, which is a research facility for medical use of cannabis in Comox on Vancouver Island. And the main wood structure is called the header house. This is the hallway of the header house. And one of the most interesting aspects of this project is that the roof spans are fairly long. It's not evident on this picture, but you see later on. So if we went with normal CLT panels, we'd have to go with fairly thick panels to make those spans, which wouldn't have been very efficient or economical. So what we did was we added some stiffening glulam ribs to the CLT panels, and we pre-screwed them in the shop to get composite action that's analogous to precast concrete double T sections. And we also did that to some of the taller walls to help with the slenderness ratio and to provide more anti-buckling resistance for the tall walls, as you can see in this picture here with the ribs on the walls. And here's another one of those spline connections between adjacent shear wall panels. This is another picture of the shear wall showing some hook down straps at certain locations as well. And here you can see on the left is a picture of the ripped roof panel supported on load-bearing stud walls on the perimeter. On the right, you have ripped roof panels supported on glulam posts and beams, which are going to be infilled subsequently with glazing. And these are some of the prefab components, including ripped panels and glulam beams. And this is another picture showing the inside of the building with the ripped roof panel supported on a combination of different systems, including solid walls as well as posts and beams. This is the clear story window. And this is a hipped part of the roof with ripped panels supported on ripped walls. This is one of the laboratory spaces in the facility. This is the finished hallway. Moving on to our most recent project, it's called the Lower Seymour Admin Building. It is office space for Metro Vancouver staff, and this building is located in North Vancouver, and we're still in the design phase on this project. So here's an elevation view of the project showing the unusual or geometry of the roof. So on plan view, you can see that the roof ridge actually cuts diagonally across the plan, which makes the framing a little bit more challenging. So basically, the roof system is, again, CLT panels supported on a mixture of stud walls and beams. So obviously, at the ridges, we need ridge beams, and then elsewhere, we also need other beams. And we have a combination of glulam beams where they're exposed and steel beams where they're concealed or where we need to lower the depths of the beams or keep them to a minimum. And one of the biggest challenges with this project is the large overhangs around the perimeter of the building. So some of the overhangs, the CLT can handle it by itself by spanning in one-way action, but the toughest challenge are the compounded overhangs at the corners. As I mentioned before, CLT panels are typically prefabricated in up to widths of 8 to 10 feet or so, which means it's harder to make them cantilever in multiple directions or do compounded overhangs. So what we had to do is introduce steel beams from inside the structure that projected out to form a front span cantilever and a back span inside the building to pick up those corners so that the CLT can span in one-way direction and be supported by these beams, and then conceal those beams in a manner so that you would not um, see them, right? And effectively, we have a hybrid structure of timber and steel for this project. The result is this plan showing the beam layout of the combination of glulam beams and steel beams. And then we have this plan of the CLT panels in different span directions and thicknesses in order to optimize the amount of material and to keep the cost down. And here are a couple of details. On the left, we have CLT panels that are supported on steel angle ledgers that are in turn pre-welded to the steel beams. On the right-hand side, we have a glulam ridge beam supporting the ridge of the roof. So the panels are screwed to the ridge beam. This is another conceptual image of this building. So to recap, we walked through a bit of our AE journey of mass timber projects, and we did a lot of different types of projects. They are very diverse. We started with the Wood Innovation Design Center, which is an institutional building. We then did some freightway terminals, a more industrial application, and then we did a miniature train station, which I would call a recreational structure. And then we did a wastewater treatment plant, which is also a post-disaster building. We did a bus shelter, a bit of a public structure in a sense. And then we have a Cannabis Innovation Center, which is a research facility. And lastly, we had the Lower Seymour Admin Building, which is a government office sort of building. So as you can see, the possibilities are endless, right? I wonder what's next. I'm excited and I can't wait to undertake the next project. And I don't know what's coming, right? But as you can see, like I said, the possibilities are endless. So I would encourage you to also consider the use of mass timber on your next project if appropriate. So thank you. Are there any questions?
There's one. For the mass timber on these AE projects to date, what was the driver of the consideration of mass timber coming from? Is it client, architect, or is it AE itself recommending this route?
That's a very good question, right? The factors have varied. If we go back to, I guess, the summary of our projects or the timeline, let me just pull up this slide or something. So Wood Innovation Design Center, we were the owner's engineer, and the client brief was that they wanted to investigate or push the boundaries of designing with timber. So that's what kind of drove the design. It was a study project or a pilot project in some ways. And then moving on to some of these other projects, the Kam Freightway Terminals, it was because of it was driven by the client once again because we perceived it as being a method of quicker installation. And then, for example, for the Kinsmen Park train station, it's more an architecturally driven project where we wanted to expose the timber for warmth and to achieve a certain visual effect. And then, interestingly, for this TFN sewage treatment plant, we at AE, we actually recommended it because we felt that the CLT for the upper part of the process building, for example, would be a bit more durable than, say, if we went with a metal structure, which is actually more conducive to corrosion or that stuff, or from the wastewater vapors and stuff like that. Whereas timber is more inert and it also helps lower the seismic mass for the post-disaster facility. And then the bus shelter is an architecturally driven project, driven largely by the visual impact that it's intended for. And then similar for the Cannabis Innovation Center, it's the inertness of timber, its relative durability for in an agricultural application compared to, say, a metal structure or a more conventional metal approach. And obviously we could have gone with, say, concrete or something like that, but it would be heavier weight and potentially more costly and take longer to construct as well, right? And then for the lower Seymour building, again, it's a bit of an architectural vision, but it's still under design at the moment. So.
Okay, I do have another one for you. Do you see mass timber becoming more cost competitive in the near future? Also, are the green building guidelines supporting the use of mass timber overall?
Well, I think it is indeed becoming more cost competitive, right? Um, these materials have been around for quite a while, and we see more plants and more fabricators opening up in different parts of North America. Uh, Years ago, we were limited to maybe fewer fabricators in the past, but now the number of fabricators are increasing, which will help increase the cost competitiveness of these types of products, and not to mention the availability of overseas products as well. So yeah, I do see that it's progressing in that direction. And then the, there was mention of green building guide.
Uh, yes. Was that are the green building guidelines supporting the use of mass timber overall?
I I have to kind of look into it more to see what the specifics are from the guidelines, but I would say there's definitely motivation to consider the the use of mass timber from different uh, guidelines or different initiatives out there for sure from different organizations. So yeah.
And more of along the lines of the cost pricing, have any of these projects had cost comparisons completed using conventional versus mass timber, and how do they compare?
Well, that's another good question. Um, I think for the projects where the client drove the use of timber because it was intended as a pilot project or where it was intended to push the boundaries, not much cost comparison was done apart from comparing between different options of timber solutions rather than comparing between different materials. But certainly for an example would be the Lower Seymour admin building, which we're designing at the moment, which the cost estimate is showing that the cost is somewhat higher than what the budget is, the allowed budget was, which leads us to have to do some value engineering to potentially kind of uh, adopt a more conventional approach with trusses or a mixture of other materials. So that's an example where we did some more realistic costing, and then many of these other projects we didn't have to do that, and we just kind of were fortunate enough to be able to proceed with it without a lot of hindrance.
Okay. We have time for one more. Are there any of the projects you're seeing ever asking for two-way implementation of CLT panels?
Yes, we are seeing more of that, and then so one example would be the Kinsmen Park train station, where even though I showed additional concealed steel members to help support the panels in one way, but in reality, there is some two-way action that's relied upon as well. And then at the Cannabis Innovation Center, there is a canopy portion up front at the main entrance where um, we had to connect adjacent panels together for some two-way action, and there's this new technology that's come out that allows you to adhere panels together for more two-way action with an adhesive, and it's becoming more widely used, right?
Okay. Well, thank you, Jeremy. That is all we have for time, and we will get ready into our second presentation.
All right. So
Our
thank you. I'll stop sharing
second
now.
presentation will be by James Broadhead and Greg Deutscher from Nomodic, as well as Esaly Wu from our Vancouver office. James is the lead of business development in Western Canada, and Greg is the senior project lead of structures for Nomodic. Nomodic is a design build construction firm specializing in modular and offsite construction. Esaly recently collaborated with with Nomodic in the structural design of the Duffin Cove Resort in Tofino, BC. Today they'll be presenting on prefabrication and modularization. Prefabrication and modularization are increasingly being used in different building sectors to increase productivity, efficiency, and quality of construction. This presentation provides an overview of market trends and benefits of using off-site prefab modular methods. Duffin Cove Resort will be used as a case study to discuss the design considerations and construction challenges of using prefab modular methods. We will hand it over to you, James.
Hey, thanks, Ashley, for the introductions. Hi, everyone. My name is Esaly. Today I'm joined with James and Greg from Nomodic to present on prefabrication and modularization. Nomodic's based in Calgary is an industry leader in modular and offsite construction. AE recently had the opportunity to collaborate with Nomodic in the design and construction of the Duffin Cove Resort in Tofino. In the Vancouver office, we've had the opportunity to use prefabrication and modularization in a number of projects, most notably pre-eng steel buildings for industrial, water, and wastewater applications, wood frame stud wall panels for multi-story residential housing, cross-laminated timber, CLT panels for institutional projects, and lastly, modular units for schools and commercial projects. So in all of these examples, we're seeing it's become commonplace that buildings are built off-site in factories rather than on-site. And to help us stay current and resilient in the construction industry, James will be sharing his insight on the prefabrication market trends. And then afterwards, Greg will be presenting a case study of the Duffin Cove Resort redevelopment. So James, I'll pass the time to you.
Thank you, and thank you for hosting us here today and inviting us to present at your conference. As mentioned, we're from Nomodic. We're one of the largest installers of prefabricated buildings in Canada. My name is James. I'm the business development lead for Western Canada, and I'm joined by Greg, who's our senior project manager and most recently worked on the install for Duffin Cove in Tofino. So this is the agenda we're going to cover today. I'm going to kind of walk through the what, why, where, when in terms of the market aspect. And then Greg's going to take us through a bit more of a detailed kind of dive into Duffin Cove through a case study. We want to make sure we've got plenty of time for Q&A at the end, but if there's any questions which are left unanswered or any follow-up, then feel free to reach out, and Esaly's got our contact information. So off-site construction. Off-site construction or prefabrication comes in many forms, most of which you are all familiar with. So if you see on the left-hand side where we look at the different types, we've kind of highlighted 4 different types of off-site construction delivery methodology. So we have panelized, and Jermyn did a great job of kind of walking through the whole mass timber market in a lot of detail. We've got volumetric, which is one of the areas that we definitely specialize in. There's component-based and then CCANs. Well, these are just a few of the different types of off-site construction methodologies that can be used for both temporary and permanent applications. I think one of the things that we come up against the most when we're talking about modular building is a lot of people have pre-notion or pre-concerns as to how the building is going to come together, because typically people are looking at that building and thinking about camps or construction offices, not the type of projects that we are quite familiar in delivering, which is the permanent modular applications. When we look at the different types of components that can go into a modular build, it's very varied. Some factories will build full houses in a factory and then deliver it to site. And essentially all that happens is it's all ready to go and just gets placed down on the foundation. And then there's other projects and other factories which is more component-based methodology, whether that's panelized or whether we're talking about mechalec rooms. So it's very varied in terms of the market. I think that for us, when we're talking to people about different types of delivery, it really comes down to each of these different options has pros and cons. And really the first step is understanding what the project goals are and what it is that the project is trying to deliver. And then with that, the manufacturing concept or methodology can then be aligned to get the best value. I think a great example of this would be if we were to look at speed to occupancy. So we do an awful lot of work in the affordable housing marketplace where speed absolutely is the #1 driver above everything else. So as a result, a volumetric delivery makes way more sense because we can do it a lot faster. Our site time is vastly reduced compared to even if we were looking at, say, a panelized system, which, like Jermyn talked about, absolutely will be way quicker than a conventional delivery methodology. But for us, volumetric will be quicker. So that's why we select that type of methodology when delivering affordable housing projects. If the goal is more around the environmental benefits, then the mass timber example that Jermyn walked through absolutely would be a great fit for the project. So why use prefabrication? On the screen here, there's a number of different benefits to using prefabrication. I'm not going to say that every single project you will see every single one of these because it's just not possible. I think that the three main reasons owners or design teams would consider prefabrication or might want to consider prefabrication. The first one being speed to occupancy. So like I talked about with the affordable housing example. The second will be speed to revenue. So what I mean by this is a hotel, student accommodation, senior living, something that has money attributed to the faster occupancy, which can offset a higher construction cost because the profit can offset it. The other part of that, which is true to both of the speed deliveries, is more around lower carrying costs, but I wouldn't say that's a main driver. So the first one, speed to occupancy, second one, speed to revenue, and then the third one is about relocatability. So like I mentioned, most people think about camps or they think about construction offices, but it's also true for commercial spaces. There's a number of people that we've worked with that have spent a lot of money on tenant improvements only to have a 3-year lease and then have to relocate and do the same thing again. So building once, pay for a building, and then relocate it if you need to later. So where we see the best fit from a market perspective, I think we need to tie this back into why use prefabrication in the first place. And all these markets on the screen are examples of where it has in the past and continues to make sense to focus, but they all have different drivers. And I think the driver is one of the most important things to try and align with, because in my opinion, from a financial perspective, it really helps to set the project up for success. So affordable housing, I've already touched on it, but I think for us, we see it as one of the biggest and best opportunities, certainly over the next 12 months. BC, as an example, has been developing and delivering volumetric buildings very aggressively over the last 3 years. And with the NDP getting back in again, it's expected that that will certainly be the case over the next 3 years. Ontario, as a market, is about to really take off. Currently, they're piloting a number of projects in the $45 million range. And then we also have the Rapid Housing Initiative, which has been brought forward by CMHC, which aims to pump around $1 billion into the Canadian modular factories next year. So affordable housing, we'd suggest out of these, is still the best opportunity for modular delivery when it comes to the reasons why you would consider prefabrication in the first place. Second to that, we'd suggest that senior living is definitely an opportunity of, or an area of focus, should I say, is probably a better terminology. Previously, the reason why we're focused on senior living projects was down to the speed to revenue. But through COVID, that's actually shifted. So the driver isn't speed to revenue, it's more around the health benefits and how quickly senior projects can be put into place. So again, that faster delivery schedule is a big driver in that particular market. Hotels. So we're going to talk about the Duffin Cove project in a few minutes, but hotels post-COVID is actually, we think, going to see a bit of a rebound. This market has gone through a large downturn in the primary markets, which is where international travelers were definitely the key driver for the occupancy rates. But there's a midterm opportunity that we see in the tertiary markets where labor shortages still exist. And there's also some excess supply which has been eroded through conversion to affordable housing, both through BC Housing, which interestingly was the largest purchaser of hotels in 2020, both private and public. And then also there's also a vehicle, from what we understand, in the CMHC rapid housing initiative for conversion as well. So we see that actually that opportunity in the tertiary markets will certainly be there in the midterm. When to look at offsite construction and when does it make sense? So labour shortages in the construction industry is a big challenge. So in some cases that might be because it's a scarce location. So if we're working on some of the islands, for example, where there isn't an abundance of labour, it makes sense to build a factory and then transport it to site. So it just reduces the overall risk and the overall cost. And then also, labour can also become scarce because of competing interests. So like infrastructure in the north, so Site C in Kitimat, when we're doing projects in that Terrace Smithers kind of belt, then it's just about the availability of trades where they can make potentially more money and have more consistent workflows in some of the larger infrastructure-based projects in the region. The other point of note is that sometimes we're competing for local labour to build within that weather window. So there might be an abundance of labour in the winter, but really we're trying to get things done in that small weather window. So an example would be that there's some retail spaces that really focus their construction efforts within the summer window, but then they can actually build all year round if they were to do it in an offsite methodology. We've actually delivered this project, which I'm showing here, which is Park Shell, and we're looking at a few more, but the retail space has obviously been highly impacted through COVID, so we expect that probably to pick up again in 2022. Environmental benefits. So the biggest environmental benefits that we see is reduction in on-site construction waste, where we are ordering components which are ordered to size. There's reduction in material wastage due to weather damage and the recycling efforts within the plant as well. So with that, I'll hand you over to Greg, who will walk us through Duffin Cove.
Thanks, James. As mentioned before, I was the project lead on the Duffin Cove project and worked with David and Esaly from AE Engineering. Just to reference the photo above there is an outline of the finished site, and as you can see, it's heavily forested all around, and when we first got there, that was carried all the way through. And the rock cliff at the very top building there, at the staff building, that actually carried through to about the middle of the building. So there's quite a bit of site development before we even got there with rock blasting. We demoed 2 buildings and quite a bit of excavation. Our scope included the staff building at the top there and the 2 3-story buildings along the cliff. For reference for this presentation, I just want to note that the steel base that the 2 3-story buildings on the cliff that we used for the foundation was prefabricated. The modules itself were prefabricated. The heavy timber walkway, which you can't really see in this photo, but it encompasses both buildings along the cliff there, was prefabricated, and then the 2 roof structures for the hotel suites were also prefabbed on site and then craned into place. Before we go to the next slide, which is about general site limitations, you can kind of see that there's a concrete retaining wall that we had to build just to the left of the building on the left there on the cliff, and that carries all the way through. So James, if you wouldn't mind just going to the next slide there. So every time we start a project, the biggest thing here is we got to figure out what size of mods we can actually use on the site. And the biggest contributing factor to that is the transportation from the fabricator. And so what we typically do is we map out the path and we kind of figure out the turning radiuses, how we're going to get there to site, and just make sure that the mods that we want to, the module sizing that we want to use is can be used with permitting and can actually get there. So we actually had a transportation study done for this, and the fabricator that we used was based out of Cumberland, but we also did it for fabricators on the mainland as well. And so typically we would ship all the mods to a location within 5 kilometers from the site, and that would kind of be our laydown area, and that also has to be contributed into the module sizing. And as a reference point to the first slide there, that retaining wall proved to be a little bit of a determining factor as well, because it had actually positioned where our crane could be. And the furthest mod, which also happened to be the biggest, was about, we were in the range of about 75 feet from center of boom of crane to center of mod. So the crane size we had to use was a 270. And then also access to each side of the building, which became quite an issue with this project, just because we had the cliff bank right on the hotel suite mods. James, can you move to the next one, please? So local site limitations. So in Tofino, BC, there is a SLEG, which was general construction material, a co-op for just a very minor construction, just tools and stuff like that. And then also in a neighboring town called Ucluelet, there was also a Windsor plywood. So access to the materials that you needed all had to be considered, especially with the Kennedy Hill construction that would often close down due to rocks in the way or whatever it might be. And the structural connections that we used were Simpson. So if you looked for Simpson GA2 clips from May to July of this year, you would find out on the island that there was a frantic man looking for GA2s everywhere and bought out the entire island. Skilled labor also was a big factor. When we got there, you soon meet, like, the civil contractor there is Gibson Brothers, and they're about as rough as you can get, but as soon as snow would come, that was a hard stop. Long weekends, for some reason, turned into 4 to 5 days, not 3. So it was interesting, but as we progressed, we made a lot of good connections, and there was a lot of really good people out there. And then, of course, in Tofino, rain was a big factor, which played into the modular positive factor that played into it. James? So considerations for tolerances. So as we mentioned in the first slide there, the steel base, the mods, the heavy timber walkways, and the roof structure were all prefabbed and had to be built within 1/8 of an inch. So this obviously was one of those things when you hear about it, it doesn't seem too bad, but when you actually consider the fact that you're not only producing a drawing, but you're having someone else build to a plan, and there's going to be a human factor in there and what's going to be the differences. And then you also have the fact that the modules over time, because by the time we built them to by the time we set them was almost a year, you have differences in settling and just shrinkage over time. So it was actually quite a method. So if you look at the bottom photo there, we built that retaining wall, and we took as-built measurements all along there. The steel base was then, that was done before the steel base. We referenced those measurements with our site plan for the steel base. Steel base was all done by, they have very accurate machines that fabricate that. So that wasn't an issue. It was the setting of the mods and then also reference to the heavy timber. So the way we had to do this is if you can see there, the piles all had anchor bolts that the steel base would sit on. Then the mods itself, we created a jig along the base of it. And so each mod that we set, we had to not only consider the X and Y plane, but we also had to consider the Z plane for the vertical, because the heavy timber had to be within 1/8 of an inch into, I believe it was the, I'll have to reference Esaly on that one, but I believe it was the floor joist that we had to anchor into. So that became quite a process. So every single mod we would set, we would then bring the surveyor in. We took 4 points on each mod at each point, and then in between each mod there's a squash pad, and that is typically a 2x6 or 2 2x6s, and in this case I believe it was 2, and we would vary that elevation based on what the elevation was once we set it. And so it worked out perfectly, but it was a little bit nerve-wracking when it's all theory and you're trying to put it all together. James, next one, please. So the structural connections, as referenced, we use quite a bit of Simpson straps for the mod-to-mod connections, as well as the connections from the roof to the heavy timber and the balconies. The structural connections from the steel base to the bottom mod was a steel angle that we put in, as well as Simpson HDU4s at specific locations. And then the heavy timber kind of connected all the way along to the retaining wall and connected the roof to the mods, as well as each mod. It kind of provided that additional kind of tie-in of the complete structure. Next one, please, James. So the benefits of doing modular on this project, one, once you get to Tofino and you see the sheer amount of rain in some days, you understand that the quality that you're producing, and you're not dealing with the environmental effects. And just when you have a crew that's working and it's raining like that, it's demoralizing. It can weigh on the crew. So that was a huge factor. The cost, obviously, that plays into it, because if you're building out there, it's very hard to judge what that can actually do to a crew and schedule when it rains like that, or any site conditions that you're really involved with. It plays a huge factor, especially if you can duplicate a mod multiple times in a factory, and by the time, if the crew's working on a mod and they have to redo it 4 times, by the 4th time they do it, it's just that much more efficient and that much more better. And safety, we had 0 incidents on this, but that plays a huge factor, just because the majority of the actual work is done offsite in a controlled setting, and you don't have to deal with those other conditions that really play into it. The results, we completed in August 2020. It's, as you can see, referencing in the photos there, it ended up being, kind of my staple to what we could do, because it took a lot out of us, and I think Esaly can attest to that. It became quite a few. There was quite a few moments where I was like, okay, I think I want to wave the white flag. I don't know if this is possible. We'll see what we can do here. But yeah, if I kind of want to open this up. I think we got 7 minutes left, so I just want to open up to any questions that you guys may have for either James or I, or any structural connections for Esaly. I would also like to note before I end here that I just want to give a good shout out to Esaly and David, because of this process that we had to do, was actually quite a bit of design build as we went. And Esaly, just from dealing with her on a day-to-day basis, she was always available, and she provided a great amount of detail on what we needed. So thank you very much.
Thank you, Greg and Wong. If anybody has any questions, they can put them in the questions box. For myself, what kind of time frame difference do you get from building Dufferin had you built out there versus in the modular sense?
Dufferin is a unique situation, just because the very first slide, like how I referenced that it was like heavily forested, and that whole cliff bank. A lot of our design and all the work that we put in for building permit was based off of a topo survey that actually became void, because once we started excavating, we realized that the ground around that cliff was a lot different than what the topo said. And so that it's kind of indifferent. But if we were able to do the excavation first, you're looking at, I wouldn't be able, I'm not sure how to put a time frame to that for this exact project, to be honest with you. But from what James is alluding to there, from a volumetric standpoint, if you can produce a project where you can duplicate a mod numerous times, if you're doing 30 mods, and so I'm on site building the foundation, doing all the site prep, utilities, everything, foundation is done, and then we come and we can, like, I think we craned 30 mods in almost 3 to 4 days. So if you can just picture, like, in 3 to 4 days, you have an entire 3-story, 4-story building, and all you have to do is the mod to mod connections. on the scalability of that, that's where you get your true benefits of modular. But for Duffin, it was a very unique project because it's hard to really showcase that advantage.
Yeah, I think just to build on what Greg's saying is that if you were to look at a typical project, you're looking around a 30 to 50% time saving. And that's effectively, we're doing the same thing, we're just changing the process. And what I mean by that is you've got design, you've got the permitting process, you've got all the site works, and then typically in a conventional construction methodology, you then start your framing. We start framing while the site work is going on at the same time. So it's the similar type of materials which have been used, the similar type of quality. You've got to make it stronger so it can be transported and it can support the loads. But in essence, the time saving comes because we're building in the factory at the same time. Typical projects, 30 to 50% time savings.
There might be more on the side. Was there more effort required in the design process for the modulars? And what's that effect on fees?
So I didn't hear the first bit of the question.
Was there more effort required in the design process for modulars?
Oh, I can answer that. So there were a lot more coordination required because each of the components were prefabricated. So for example, the heavy timber platforms, the modular units, the steel platform, they all came from different vendors, and we have different shop drawings. So coming up with a connection to transition between those different components required more design. In terms of fees, again, I would say same as Greg. It's a unique project. So I think most of our design effort went into coordination and connection design, whereas there are some components that were designed by other parties that would help offset some of the design effort.
What we see on typical projects, and again, I think we've made a point a number of times that Duffin is very unique, which is why we wanted to talk about it today. What we typically see in terms of design time and design fees is that it's very project specific. So where we get repeatability and we're using design groups that have schematics or light components that they can draw from and replicate for future projects. So where we've got that repeatability in design from different locations, that definitely helps us. By nature, modular typically goes faster because that tends to be the biggest driver. So we try to, and we don't always get this right, but we try to limit the amount of design changes within the process. We try and do design sprints which incorporate the client as well, so that we can hopefully reduce design fees and design time by not having multiple changes and iterations. So that's what we do, which is again in a normal process versus Duffin.
And just an added note to that, for design considerations, typical mod widths are 12 to 14 feet. So you would kind of try and group your shear walls and all that along those planes. And then you also have to consider your mechanical electrical chutes as you go up from each story. Those are kind of the main considerations and playing into it. So it does add a little bit of modular component to your design, but there's always ways around that.
And we have time for one more. How much of the interior finishes and systems, like your HVAC and electrical, is completed prior to taking them to site?
Is that a generic question or a question specific to Duffin?
Just overall.
It's varied. Every project is different, and I think just kind of relating back to Jermyn's presentation there, a lot of these projects can incorporate hybrid construction, and so in those types of projects, we have to leave more exposed. What we try to do is if you kind of break it down by category, so you've got like hotels, senior living, affordable housing, we try to complete the rooms as much as possible, 100% within the factory. And then depending on where it's going, what the rezoning requirements are, the level of experience with the factory that we're building in, we might elect to do things like the siding on site, but we try and get as close as we can. It's somewhere between about 70 to 90% completion. With things like double loaded corridors or common corridors will be left open. And like Greg was talking about in terms of the shafts, to be able to run some of those site components, you still need some of the accessibility. So you for multifamily projects, you're never going to be at 100%. For single family, you are. But typically for us, the mainstay would be in that 70 to 90% range, which is purely project specific.
Well, thank you very much. It was a very interesting presentation, James, Greg, and Esaly. And I think we are out of time. We're going to now take a 30-minute break. I encourage you to take the time to network with other attendees using the event networking area. You can connect with colleagues by going into the networking area at the bottom of the virtual lobby page and searching by clicking your colleague's name. And yeah, please take advantage of the networking space to connect and share your experiences. And thank you very much for joining us today.